Hi everyone, welcome back to workshop, or rather the electricity cupboard in the house. I've got a little project on the go in the home at the moment, and I just thought I'd share it on YouTube. This is the consumer unit at the top there, but I've also got the solar panel generation meter down here with its isolation switches at the bottom there, and the standard electricity meter, which has got nothing to do with the solar system there, the incoming supply electricity meter there. And this video is in relation to a problem that I think maybe UK installers of solar systems seem to have at the moment, and that's when I compare it with other countries anyway. And the problem is, when you get a solar system in the UK, a bog standard install, you will get a generation meter, but you've got no way of seeing what power you are exporting and what power you are importing, i.e. consuming, at any point in time. There's no extra meter, there's no way of knowing that. So what I have done up until now is I've got a couple of little radio transmitters here that feed off of the optical LED on the generation meter there. There's a little a photodiode inside that black unit there, and similarly on the main household incoming meter as well. There's a flashing LED that the rate at which it flashes is proportional to the power that is being consumed or exported. And that's where the problem is. This pulsed output here will flash irrespective of whether you're importing power or exporting power onto the grid. You've got no way of knowing whether you're importing or exporting. Now you can sort of work it out, and I've got these two radio transmitters like I said, and in the workshop I've got two display units. One will show the kilowatts being generated, and the other one will show the kilowatts being imported / exported. And obviously if the generation goes up, then you can see that reflected on what the import-export meter will show. However, like I said, you can't tell whether you're importing or exporting. And the other problem is that data is not connected in any way, shape or form. I like to see graphs, I like to see tables of data, and you can't get that with this here. I can log on to the inverter, which is up in the loft, which I'll show you in a second, and extract data from it, but it is just generated power and obviously the historical logs of what I've generated over time. But again, that's not linked at all to what I'm importing or exporting. So I'm going to fix that, and the way I'm going to do that is I've got one of these here. It's an OB418 meter, and it's going to go in series with the existing meter, probably cutting that cable there and inserting it there. And this meter here is an intelligent smart meter. It has a Modbus interface on it, and I can log into this unit and extract data from it live, and see exactly what I'm importing or separately what I'm exporting at any given moment in time, amongst other things like voltage, current and all that sort of thing. So I'm going to mount that there, and there'll be a Modbus interface at the top there. And what I'm also going to do is I'm also going to have a little junction box at the right hand side where I'm going to put an Arduino with a Wi-Fi connection, and that's going to connect to the Modbus interface and decode it and present the data. Now, of course, the generation meter is separate, but that's going to be incorporated as well, because I'm going to redirect this optical interface. Instead of going to one of my radio transmitters there, it's going to come up and into the Arduino as well. So the Arduino is going to see everything here: import, export and generation, and from that I can work out consumption and all that there. The output from the Arduino with its Wi-Fi connection is going to go to pvoutput.org. pvoutput.org is a website that collates live solar PV data from around the world. So I've had an account with them for a couple of years now that I've been exporting my generation power, but not the import export. So I'm going to incorporate everything now. pvoutput.org has all graphs, etc. You can see exactly what's going on, and it also logs it as well, so you can roll back to any day or month, etc. in the past, right up until you started logging, and see all that data. I don't need to make an interface myself to do that, you know, graph generation, etc. So I'm going to get my local electrician who's going to come in and fit this meter for me. In the UK, we're not allowed to do that ourselves. Has to be a certified electrician. So obviously he'll reroute this grey cable here, probably stick it there or up here or something like that. It's up to him. And then once that's done, I'll then start mounting my own Arduino and work on that. So let's take a look upstairs at the inverter. There's nothing going to happen upstairs, but just let you have a look and see what we've got there. So here's the actual inverter itself. It's up in the loft, the property. It's a Bosch inverter. It's a 4 kilowatt system that I've got. And here's the isolators here. I've got 16 panels on the roof, set up as 2 strings there. So I've got 2 isolators, one for each string there, and then a main isolator there. So there's not really much to see here. That I won't be connecting to the inverter itself to get any data out of it, although I could do. I have done that in the past, because there is an Ethernet connection there. You may be able to see the Cat5 cable coming down here. That goes away down on into my network in my LAN cupboard downstairs, and I am actually able to extract data from the inverter itself and get a lot more. I could get the current per string of the panels, etc, etc, but in actual fact I don't really need all that data. So I've decided not to use the direct interface into the inverter itself. I'm going to use the pulse output on the actual generation meter and just take that into one of the Arduino inputs. And just for completeness, these are the 2 display units that are at the other end of those 2 radio transmitters in the electricity cupboard. The one on the right here is one connected to the generation meter. You can see at the moment I'm generating 2.54 kilowatts, and on the other one here, this is the household electricity meter. It's displaying 539 watts. Now, like I said, it doesn't tell you whether you're importing or exporting. So here's the OB418 meter here, and this is the box where the Arduino is going to go. Now, I did say Arduino, and yes, I will be writing using the Arduino code, but actually it's going to be an ESP8266 here. This is one of those ESP8266 Wi-Fi modules here, nodemcu. I've used these in the past in and around the home, so I'm just going to write one of these. It's fully compatible with the Arduino IDE, and I've got bits and pieces of code that I've written for one of these before, so I'll be able to reuse that there. So that's the box there, and I'm just going to mount everything on a bit of board here, perf board, just single-sided stuff there. That'll do the job nicely. And I'm going to have obviously the 8266 itself, and I'm also going to need something to convert the Modbus connection of the OB418 into something that the 8266 can read. Now, what you need for that is an RS485 to TTL converter. So I've got one of these here that I picked up off of eBay, and that's because the Modbus is a software protocol which runs on an RS485 hardware protocol, for want of a better word, and therefore I need to convert that RS485 to TTL comms that the 8266 can read. It's just a serial interface. So the Modbus side of things, RS485, is just 2 wire. You've got A plus and a B minus, and there'll be a corresponding A plus and B minus on here. There's a couple of other signals that are available there, but I won't be using them. I'll just basically be connecting 2 wires and possibly the ground wire, though it's not actually needed. I will be connecting those in there. It's with a short cable that will run from the OB418 into the small junction box here. And just for so I can see what's going on without logging on to the 8266, I've got a little OLED display here. I think it's 32 to, no, it's 16 by 8 characters or something like that. Just a simple little display there. I've used one of these prior as well, so I've got a library all set up for that there. So that's basically all I'll need inside the junction box. Very, very simple, and hopefully it will be reliable. And obviously the Wi-Fi connection is required in order for the data to get from the 8266 out onto the internet and into pvoutput.org. Now, I have actually been using pvoutput.org a couple of years ago in a much more basic format for just outputting the generated power from the solar panels out onto the web, onto pvoutput.org. That was without the import and export data accordingly. And this is a little bit of kit that I was using back then. It was in a small junction box, very similar, and again it uses the 8266 and exactly the same OLED display. So I can actually power this one up because I've been doing a little bit of development work already on the software in order to be used with the 418. So in order to output to pvoutput.org, you need to send the a timestamp with the data. So I need obviously the Wi-Fi connection. I go to an NTP server, pick up the time, reformat it into a format that's suitable for pvoutput.org, and that's it there, the 2021-04 and the 24th day of the month, and then the current time, which is 10:43. And I've had to rewrite some of the software to take care of British summertime when the clocks go forward and back, etc. So I want all that to be automatic. I don't want to have to go and log in and change the time or muck about with the software. So it's all automatic now. Daylight saving is taken care of. So once it does connect to Wi-Fi, I might have a little bit of trouble with it connecting to Wi-Fi inside the workshop here. It's a bit like a Faraday cage, but sometimes it does connect. There it goes. It's picked up the Wi-Fi connection. Just took a little bit of time. So what I'm going to have on the display here is the current live readings in watts. So the import, export, the solar generated, the consumption of the house. That will be calculated from the import, export and solar generated, and the voltage and the frequency, which comes from the OB418. So the next thing I need to do is cut the perf board to size so that it will fit the enclosure and start mounting everything onto the perf board. But I also need to add a little bit of extra electronics on the perf board to take the pulse signal from this photodiode, which goes on the front of the generation meter, that will give me the generated wattage from the solar panels, and I need to interface to that there and convert that photodiode signal to a logic level that the 8266 can take. It's running at 3.3 volts, so I need to do something there. So that's fairly easy, just an FET, a couple of resistors and a capacitor there will take care of that there. So I'm actually going to make it dual channel. I've got two of these, and that's just in case I want to take any data from the existing electricity meter in the house, although the OB418 should give me absolutely everything I need there. But I'm just going to add that extra channel onto the board here and interface it to the 8266 just in case. And the idea is that I'll put a couple of 3.5mm sockets on the side of the box here for plugging in the photodiodes. The Modbus connection is going to make use of this little 4-way connector here, a panel connector there, so that I can easily remove the box, obviously take it back to the workshop if I'm writing any extra code or troubleshooting, etc. And that cable will then go away off and interface to the OB418 here. So I'm getting on quite well now with the enclosure. I've got the ESP8266 in place. I've got the pulse shaping circuit for the photodiode inputs. I've got two of them there, and I've got two of the sockets there. I'm just using one at the moment. The OLED's fitted. I've not fitted the RS485 to TTL converter because the ESP8266 only has one COM port, and that's therefore the this board here, the RS-485 converter board, shares it with the USB comms. So when I've got that board plugged in, the USB comms doesn't work for uploading new code. But once the development's done, I can sort that all out, and I can just plug the board in and it'll work. But the reason for showing you at this stage here, I've got a rather novel way, for me anyway, of testing the photodiode, which I've got plugged in here. So if I just turn the camera around, so you can see that I've got the photodiode here attached to the front panel of channel 2 of this power supply here, and it's actually channel 1's the same, and there's actually a green LED here which signifies the channels on or off, and I can demonstrate that with this one here. If I just turn the channel off and on again, I've got control over that LED here. It's a bit better than using a torch and shining it into the photodiode. So therefore, if we just turn off and on the second channel, that LED is going to cause the photodiode to react. So if I swivel back to the board, I've got a little pulse counter on the top there. It's currently sitting at 3. So if I just actuate that channel on and off, you can see that every second press of the button, it's counting up rather nicely. I had a little bit of a debounce problem to start with, but managed to fix that in the software so that it basically reacts perfectly once per LED action there. Well, roll forward a couple of days and we're up and running. I've got the new meter fitted. As you can see, it's in series with the original meter, which has got to stay. You can see the power coming up through this meter and then up into my fuse board at the top there. And you can see that I've also got my junction box with my 8266 running, and it's all tied in. I've got the Modbus communications just temporarily hooked up. I'll tidy up the wiring later on. I've got a termination resistor there which I need to tidy up, and I've also fitted just up a little bit. You can see I've also fitted a double socket just so that I can power the box here with a USB. That'll just stay there permanently. I might put an inline USB fuse in series with that cable just to protect things, because this cupboard's usually full with jackets and boots and all sorts of stuff in here. But so I really want to make it safe as possible. So zooming in on the unit here, you can see that I've got the little OLED display is actually displaying some useful data at the moment. I've got import, export, solar generation power, and power consumption, and also voltage. Now what you will notice is that I haven't actually hooked up the pulse inputs from the generation meter, which is just off camera there. I've decided not to do that. I looked at my original code for the project that I used to have running, and I was actually, like I said earlier on, I was connecting to the Bosch inverter, the solar inverter up in the loft, through Wi-Fi, and I had a look at the code again, and it was always a little bit unreliable in the past. Well, I have improved things. I think I've identified why it was a little bit unreliable in the past, and I think I've fixed that now. So I don't need to actually use the pulse inputs. I'm getting much more accurate information directly from the inverter itself. So I've got a power figure there. The sun's still out at the moment, and it's reading about 600 watts at the moment, and it all seems to be working no problem. There is a slight issue with the new meter, which I actually had to call the manufacturer about. There's an alarm light here, and every now and then that alarm light would come on, and they're telling me that if you've hooked up the connections wrong and you feed current through the meter backwards, the alarm light does come on. However, that's exactly what this meter is used for. It's used in a situation where you might be importing or exporting power. So why the firmware's got a little bit of a bug like that, I don't know. However, when the alarm light does come on, it doesn't inhibit anything whatsoever. You still get good data on the Modbus comms. You still get a good import and an export figure depending on which way the current's flowing. So you will get a negative power when you're exporting and a negative current when you're exporting as well. And obviously I've converted those figures there before I upload everything to pvoutput.org. I'll put a link down below if you want to go and have a look at the data that's coming in already. I've still got to play about with the power consumption figure. There's a little bit of work to be done there. It's not straightforward to work out power consumption for the home. And I will need to think about that to work out exactly what's going on. And you can see the alarm light there has just come on. Obviously we're exporting again. The solar panels are producing more power than what the household's actually using. So far so good. I've still got a little bit of tidying up of the software to do. I'm going to leave it like this just to see how reliable it is for the rest of the day. Just to see what happens there. I've put in extra code in the software so that it will restart things if the Wi-Fi drops, etc. And the reason for that is there's quite a lot going on in that software. If you think about it, there's Modbus comms to the meter, there's a Wi-Fi connection to the inverter up in the loft, there's a Wi-Fi connection to pvoutput.org. So there's a lot going on that little Arduino compatible 8266. But this is what I wanted all along since I installed the solar system, what must be something like 3 years ago now. I was always a bit disappointed that all you could see was the power generation figure, either from the power generation meter down here or by logging into the inverter itself. I never really had anything else apart from maybe picking up the pulse signals from the meters that we've got there, but I was never happy with that. It was always broken up. That was never tied back to one central place to then work with the data and present it. I've got a little transparent cover for the box here, so I like to see what the display is. It means I can open the cupboard here and have a little look to see what the figures are doing, just to make sure everything's running okay. And that's the way we're going to go forward. So let's go and have a look at the software. Let's go and have a look at pvoutput.org and see what we've got there. So here is the source code. I am going to make this available just for download below the video. Hopefully I'll be able to do that straight away if things are reliable enough by the time I publish this video here. There's quite a few routines in here, or libraries, that I do make use of that I think would be interesting for other people to use. So this is the main opening screen for pvoutput.org. I should be able to link you to this one if you want to have a look. And as you can see down the left here, I've got some prior figures that were uploaded. So the last time I actually used pvoutput.org was back in March 2018. Has it been that long since I had a system uploading? Wow. So there's today's date there with the entry for today. I can actually go and click on that. Where's the mouse? There we go. And I'll open up today and you can see the entries that have been published so far. I think I've got it configured to upload every 10 minutes. Yes, that's every 10 minutes. First one started at 4:35 p.m. and you can see the various figures there. The power, the generation, the average, normalized, temperature, voltage, energy used. I do need to figure out how to configure these columns because I am uploading import and export figures there, so I need to take a look at that. And also the graph here, I need to work out how to get the multi-lines on that graph there, because that's just the default ones at the moment there. And you can go along and look at the live data, the daily, weekly, monthly, yearly. There's analysis functions, etc, etc. Some additional detail about the actual enclosure that I've got here. Obviously I've got the 8266 Arduino compatible board there. I've got the OLED display, and this little board here, that's the current RS485 to TTL converter that I'm using. I was playing around with another one, but I couldn't get it to work properly. The reason for that is it's half duplex comms that I require, so therefore you can't transmit and receive at the same time. So I had to find a way of auto switching between transmit and receive. Now luckily this particular board has got it built in. It's normally in a receive mode, but if it detects a transmit signal from the 8266, automatically goes into transmit mode in order to talk back or request data from the meter. The other one that I was using, which there is still reference in the software for, is a manual one. It's got 2 digital inputs on the board that you can use to toggle between transmit and receive. But that one wasn't really working properly. This one worked out of the box straight away. And in fact, this one's got a couple of LEDs in it, one for transmit and one for receive. So if you wait long enough, you'll see a light come on as the data is going out, and immediately afterwards you'll see a light come on as the data comes back. So that's it for now. I'm just going to leave it running, make sure it's reliable enough, and maybe in the next day or so, if it's all working out well, I will tidy up the wiring. I need to especially tidy up the wiring where it goes into the meter, and bolt this properly to the wall. I've just got it temporarily hanging on a bit of DIN rail there, but I will screw the junction box directly to the wall and make sure everything's tight. And if I've got any updates or small updates, I will put that in the comments down below. If there's any big updates, like a change direction with it or anything like that, I'll probably do a follow-up video. Thanks for watching.